So with differential equations, there are basics that you did in first year and second year. First year for calculus, MAT 1512 and MAT 1613. So this one here, we're going to eliminate some of the steps when we are doing this module. So I'm going to assume maybe you know them. So I'm just going to give you the definition. And we're going to do also some examples. So by a system of a first order linear differential equations, we mean a set of a simultaneous equation of the form of x, we can say x1 of t, whereby equals to, we can say a1, 1 of t, x1, plus, it can be a1, 2 of t again, x2 plus a 1 of n of t, xn, and then we can also have x1 of t, which it can be a21 of t, x2, x1, plus a2 of 2 of t, x2, plus dot up to plus, yes, also must be plus, up to plus a2 of n of t, this is n here, of xn. So this will go up to x of n of t, which is we can say an1 of t plus x1 plus an of 2 of t, x2 plus dot, and then plus nn of t of xn. So this is the first order linear differential equations. So in this first order linear differential equations, we have a homogeneous system, and we also have non-homogeneous system. So when we talk about homogeneous system, so if in this equation that I just wrote now, if I add, let's say we can add q after the end here in each and every, we can add plus. If I add plus, let's say it's gonna start with q, let's say q1 of t. Then the second one here, I add q2 of t. Then I also add q of n of t. So if our q1 of t or qn, both of, if all these, they are equals to 0, then our system is going to be homogeneous. It's going to be a homogeneous system. Will be homogeneous system. So when it's homogeneous system for n here is going to be starting at 1 until n, and then when the equation is homogeneous, it won't, because our x of 1 t, x of 2, all these are equals to 0, is going to be exactly the way I've written here without q of t. So thus the one that I just wrote now it's a homogeneous equation. So this homogeneous equation, we write it as x bar, x of which is equals to A. We can write it in the form of a matrix, which is equals to A of t of x. So in this form here, our A of t is going to be equals to, our A of t is going to be equals to Aij of t, and our whereby I and j equals to 1, 2, up to n. And then the x is going to be equals to x1, x2, up to xn. So in this way, I have written this matrix in a transpose way. I will just write a T for transpose. And then also the same applies to x bar, whereby if you write it in a transpose, it's going to be x dot 1 up to x dot n. So with this, what I've given it here to you, if we have to, we also have some definition. So the definition that I'm gonna also state is the definition of a higher order, a definition of a higher order system, with a constant coefficient of a system of the, with a constant coefficient of the system of the form, whereby we can use a P11. Then when we use a P11 of D, so this D here is it means that it's a differentiation. It means differentiation. The D that we are using see here is the same as dy over the, it can be dy over dx or dy over dt, depending on the format of your system, how it is. Because here is a x, we can say dy over dx. So it's gonna be x1 plus P12 of D, x2 plus P of 1n of T of D, sorry, not T of D, xn. So this equation is going to be equals to something which we can name it h1 of T. So if we go, you're gonna end up having P of n1 of D of x1 plus P of n2 of D of x2 plus until it goes to P of nn, P of n of D of xn, and this is going to be equals to hn. I will just write hn of t, hn of t. So this is the higher first order of this differential equation. So where all the Pij is the same as Si and j is 1 up to n are all the polynomial differential equations. So if we get the determinant of this matrix, we just take the coefficients, which are P11 of D up to Pn of D, and then when you go, it's gonna be P of n 1 of D into Pnn of D. So this is called the determinant of the one that I just deleted is called the determinant of the system. So I'm not gonna state the definition of there is a definition that I'm just gonna state it, but I'm not gonna write it here. A solution of the system of a differential equation is an n-dimensional vector equation. So when we say that the dimensional vector equation, there will be x1, there will be x1 of t and x2 of t in a transpose way. So the theorem that we're gonna state is the theorem of the superposition principle, which is a theorem 1.4. So the theorem 1.4, it states that any linear combination of a solution of a system of differential equation is also a solution of the system. So now I will do an example with you, whereby we're gonna be working based on that example and how to solve it. So the solving part, I'm gonna explain step by step how the solution is achieved. So this question is gonna be a little bit longer. If we have this question that I'm using here is in your study guide. If you check your study guide, you're gonna find this question with a solution. But with that solution that they give in your study guide, they eliminated some steps. So if you are checking it, you might find that you are a little bit confused because there are some steps that were eliminated. So if you have, they say, this is -2 e to the power 2, 2t, and also this is a t here, and also e to the power 2t is in the form of a transpose. And also you have e to the power 3 t and -e to the power 3 t is also in the form of a transpose. Is a solution of the system. This is the solution of the system, which is x1 equals to x1 minus 2x2 and then x2 equals to x1 plus 4x2 for x2. So now when we solve this, we're going to apply theorem 1.4, the superposition principles. So when we apply theorem 1.4, we are going to put the constants. So when we put the constant, we're gonna name them C1 and also C2, and then C1 and C2. So when we apply theorem 4, it's going to theorem 1.4. Our equation here, this one is the first one, and this one second, and second. So which means we're gonna have minus 2c1 e to the power 2t, then plus, we take this one here, is going to be c2 plus c2 e to the power 3t. So we introduce C1 and C2. This one is still C1. It's going to be C1 and C2. It's the C1 and C2. C1 and C2. So we're going to put a comma. Then C1 e to the power is this one that I'm writing. E to the power 2t. Plus this here is negative here. It's going to be minus C2 e to the power 2t. Is it 2? No, sorry, it's 3t. This is 3. We're going to write 3 there, 3t. In a form of transpose. So when we have this now, so if we have a differential equation whereby this is how you'd write it with the theorem 1.4 with a superposition principle. So now let's assume we have this differential equation, d squared y, d squared x squared, d squared x over the x squared, the x squared minus 4x plus, this is a system of linear system, plus dy over the x, dy over the t. Sorry, this is not x here. We must change it to t. You must also change this one here to t. And here it must also be changed to t. Sorry, not to t, to x. Sorry, yeah, this one is fine. To x. Then we also have maybe a question again. This is equals to 0. Is equal to 0. So let me just erase this part here. It's 4x. So we also have another one, which is d squared tx. This is x here. Just that I forgot to change it, but we just remember the x squared over so this one here is going to be a, let's say, negative 4 dx over dt plus d squared y over dt plus 2y plus 2y, which is equals to 0. So in this equation here, we are going to apply the d operator. Hello?
Hello?
Yeah. I think you were saying something.
Is this a new question?
Yes, this is a new question. Yes. So this
Okay.
question here, which we are doing here, we are going to be applying the d operator. We call it d operator. So when we apply the operator, remember the d operator, I showed you that the d, it means dy over the x. So if we have dy, let's say dy over the x, or it can be dy over dt, this is the same as equals to d. Then if you have d squared y over dt squared, this is the same as d squared. You must just remember that. So now we're going to convert these two in the form of d. So when we convert those two in the form of d, the first one here you can see we have d squared x over dt. So this one dt squared here is dt squared. So this one is d squared. Then we have minus 4x. So this one minus 4x here, it can be represented as just minus 4. And then plus, we can maybe bracket this, plus dy over dt is going to be just d, because it's only dy over dt, which is equals to 0. So this equation here, which I just did here, we can name it equation 1. When we name it equation 1, this side, if you see dy over dt, it was of the form y, né? And d squared minus 4, it was of the form x. So we can also include that. So we're gonna name this one as equation 1. And when we go to this one, is minus 4. The second one, dx over dt, which you can just write d, plus d squared y over dt, we can name is, so now d squared y and dy here is y in the form of y. So which means I can write here, let me erase this positive first. Then I can write this one here in the brackets. I indicate that is for the form of x. Then plus, now these two, they are in the same form. So it's going to be d squared plus 2. So I can bracket this in the form of y. Then this is going to be equals to 0. This is, we can name it equation 2. It's our equation 2. So when it's equation 2, now we just converted it to the form of a d. So now we have to solve. In this question here, we have to find the question here, we have to find the solution. It's like we are finding the general solution of this linear system. So in order for us to find the general solution of this linear system, we have to solve for x, and we also have to solve for the y. So when we solve for the y, in second year differential equation, you did about explicit differentiation and implicit differentiation. So we're gonna mix that also with the first year method that we used. So when we mix that with the first year method that we used, we know that if we want to eliminate, if we are working with a simultaneous equations, if we want to eliminate this side here, we must make this one to be equals to this one so that we can get 0. So in order for do that, we're gonna multiply the equation 1 with minus 4d, and then we're also gonna multiply equation 2 with d squared minus 4 so that we can eliminate the side of x. So if I multiply equation 1 with 4d, I'm multiplying equation 1 with 4d, then my equation is going to say, it's going to be in the form of 4 in brackets d cubic minus 4d. So if you say 4d, if we say minus is 4d, if you take out 4, we say d times d is going to say d cubic, and d times 4 minus 4 is going to give us minus 4d. So for this 4 is this one here, which is, if we multiply everything, is going to say 4d cubic plus 16d. But we can just take it out just for factorization. Then when we have done that, this is the side of x, and then plus the same minus 4d is going to multiply all this equation here. So which means when we multiply this one, this is d of y. So in the form of d of y multiplied by 4d is going to give us 4d squared. And this one 4d squared is going to be for y, which is equals to 0, because when we multiply 4d by 0, we're still gonna get 0. So this equation, we can name it equation 3. Then we're gonna multiply equation 2 with d squared, with this here, d squared minus 4. So when we multiply it with d squared minus 4, equation, we are multiplying equation 2, we're going to obtain also minus 4 in brackets d squared minus 4 is going to be minus 4 in brackets d times this d squared is going to give us d cubic, d times this one 4 is going to give us minus 4d in brackets minus 4d in brackets. This is the side of x, and if we multiply this one 4d squared for this one d squared plus 2, d squared plus 2, we multiply it by d squared. Let me just write it here. If you multiply d squared plus 2, you multiply it by d squared minus 4. The answer here when you is going to be d times d is going to give you d to the power 4, and then minus 4d, d to the power 4 minus 4d squared plus 2d squared and minus 8. So when we solve this one here, our answer is going to be d to the power 4 minus 2d squared minus 8. So we can write this answer, this side, in the form of a y. So we're just gonna write that, we're gonna say plus, then the final answer for that is going to be in brackets d to the power 4 minus 2d squared minus 8. of, this is in the form of y, which is equals to 0. We can make this to be equation 4. So let me erase this one, this part that I was showing you. So now when we have done that, so we can take equation 4, we can take equation 3, we add it with equation 4. So when we add this plus this is going to give us 0. And then this one, this side for y, this one for y plus this one for y, they are going to give us d squared let me calculate properly. Just give me a few minutes. So they are going to give us, if you check here, we have for number 3, we have, for equation 3, we have plus 4d squared. So which means we're going to say the answer is going to be d to the power 4 plus 4 minus 4 is going to give us plus 2d squared. This 2 there, then the minus 8. Minus 8. This is in the form of y. And this is equals to 0. Equals to 0. So now we can say the answer that we have here is d to the power 4 plus 2d squared minus 8 in the form of y equals to 0. Then we can use, you can use m or you can use r. It's either m or r in these letters. Then I'm gonna go with m. Then this is, we can write it as m the power 4 plus 2m squared minus 8 is going to be equals to 0. Then now when we have this, we can factorize. When you factorize, you can look, if you don't understand, you can't get the factor, you can use, you can get the factor, then you can use a long division. So when you use a long division, you're gonna come to a point whereby you will find that 2 is a factor. So your calculation will bring you to 2 squared, m squared plus 4, and m squared minus 2. You use a long division. So when you have this one here, when we have this one, then our m squared is going to be equals to minus 4, or our m squared is going to be equals to 2. So now when our m squared is going to be equals to 2, minus 4, remember, if we have square root I equals to square root of negative 1, so which means m is going to be equals to plus or minus 2i, because square root of 4 is 2, so it's going to be plus or minus 2i, because square root of negative 4, we convert it to I in a complex number, and or our m here is going to be equals to plus or minus square root of 2. It's because of we are squaring, we square, even this side we square square roots. That's why we get these two numbers. We have a complex number and we have also a real number. So when we have a complex number and a real number, in terms of let me just delete here. In terms of a complex analysis, when we work with a complex number, when we were dealing with if we are doing cost MAT3507, the complex number e to the power I negative e to the power RT is cos theta plus I sine theta, but it can be converted by De Morgan theorem to become cos n theta plus sine n theta. So this, in this form, we're going to write our, we're gonna change it to our in the form of those point. So because of we have, let me just rewrite them properly. Because we have our m, which is equals to plus or minus 2i, or we also have m, which is equals to plus or minus square root of 2. Then when we write a solution, because these are solutions of what? Of y. So when we write the solution of y of t is going to be equals to, if I start with this one here, we introduce c1, is going to be c1 e to the power square root of 2t plus, then is gonna be plus c2. Are you still here?
Yes.
Jesus, I was
Hello?
talking alone. Okay. Are you, did the network took you alone? Okay, like how long did you understand the other things I was explaining?
Yes, most of it.
Okay, let me just go back a little. Then is it we get our m equals to plus or minus 2i, or our m equals to plus or minus square root of 2? This is in the form, is this a solution of y? Then our y of t is going to be c1. This c1 is an arbitrary constant. Okay, then it's going to be c1 e to the power. We introduce in differential equation for second year. You learn that when you want to get a general solution of a system, we'll say e to the power rt, if you still remember, plus c2 to the power rt, and then plus, if you have like maybe if your solution were having, let's say, 2 square root of x plus x, is gonna be, say, c3x e to the power rt, if you still remember that. So we are using the same method. So in this one here, we got these two, m1 and m2. You can even name them m1 and m2. So now we're gonna have c2. I'm still working on the square root of 2. It's gonna be e to the power negative, is plus or minus, remember, negative square root of 2t, plus, again, I have plus 2i. When is I, we are going to use plus or minus 2i. We are going to use the one for cos and sine. For cos and sine, we will have c3. Gonna say c3. Because it's plus or minus, we're gonna have c3 cos of t2. This is t2 plus or minus. Then you're gonna have plus, and then c4 sine t2, sine 2t. So this equation that I wrote is coming from the equation whereby you will say for the complex number e to the power rt is equals to cos of t plus I sine t. So this cos of t plus I sine t, when we calculate, when we add e to the power rt of, when here normally we're using in the rt, let's say when we are using the z, whereby your z equals to x plus I1, then in terms of De Morgan's, you can write it as cos of t plus sine of t to the power n, whereby when you convert it, you can change it to cos of nt plus sine of nt, like this way. So this formula that I just gave it to you here, you normally see it in your books. It's just a general formula whereby if you are working with I, when you only have I without any number in the before I, maybe if you just plus or minus I like this, you only write it in terms of cos. you can say cos t based on which variable it is, cos t plus sine of t. So now if we proceed, when we proceed with this one, you will find that we already wrote that. So this is our solution for y of t. So what is the solution for y of t? We're gonna need to find the solution for x. We only found for y. So when we find the solution for x, we are going to use we are going to substitute this equation. We'll substitute this equation in equation 2. Our equation 2, remember, is minus 4d of x plus in brackets d squared plus 2. Let me just write it down. We are going to substitute this equation here. We are going to substitute in equation number 2, which was minus 4d of x. This one is 4d of x plus in brackets d squared plus 2. And this is for y, which is equals to 0. So now when we substitute in this equation for d squared, we have to differentiate this. You first differentiate this equation 2 times, first and second 2 times. So we're gonna first find y prime of t. I haven't substituted it here. When I find y prime of t, my y prime of t, you're gonna see that is going to be C1. When we differentiate e to the power square root of 2t, we're going to get square root of 2 C1 e to the power square root of 2t plus, when we differentiate negative, is going to give us, change the sign here to be negative square root of 2 C2 e to the power negative square root of 2t. Then when we differentiate cos, when we differentiate is change sign to negative, and there is cos 2t here is going to be minus 2c3 sine of what? Sine 2t. Then when we differentiate sine 2t is going to be plus 2c4 cos 2t. Cos 2t. Then this is a y prime. Then we're gonna find y, second y, y prime of t. Then if we differentiate, this one is the square root of 2 is going to come down. Square root of 2 times square root of 2 is going to give you 2c1 e to the power square root of 2t minus, when we differentiate, this one is going to be minus square root of 2 minus square root of 2 is going to give us plus 2c2 e to the power negative square root of 2t. Then when you differentiate, sign here is going to be negative 4, because it's 2 here, 2 times 2 gonna be negative 4 c3 cos 2t. When we differentiate cos, is going to change sign to negative again. 4 is, there is a 2 here, is gonna say negative 4 c4, and then sine what? Sine 2t. So now when we substitute back, when we substitute in there, that equation here, the one that we have to substitute, we are going to get, when we substitute for that equation, we are going to get, we are going to say, you're going to say, everything you are going to use here is for d squared. We just differentiated this. You are going to add this. And then after that, the real equation, you are going to multiply by 2. This 2 here. The equation that we didn't differentiate it is this one. Y of t, you are going to multiply everything by 2. When we multiply everything by 2 here, if we multiply this by 2, it's going to be 2, 2, 2, and 2. This is plus here and 2. So now because it's going to be this equation, if I multiply it by 2, I will add this one and this one. If I add this one and this one, you will see that 2 plus 2, if I'm adding them, 2, this term, the like terms, 2 plus 2 is going to give me 2c1. This one and this one is going to give me 4, not 2, sorry, 4c1 e to the power square root of 2t. If I add this 2 and this one is going to be plus 4 again, c2 e to the power negative square root of 2t. And then if I get minus 4, c3 plus 2 is going to be what? Minus 2, minus 4 plus 2, minus 2c3 cos what? Cos 2t. Minus 4 plus 2 again is going to be minus 2c4 sine what? Sine 2t. So now when I have done that, this one now I can add it to my equation, then which means I'm gonna have minus 4d of x, minus 4d of x, plus, I only substitute this because I already done the calculations. I already add them. You just say plus, you add everything the way it is 4c1 e square root of 2t plus 4c2 e negative square root of 2t minus 2 minus 2 just give me a moment, let me check something. Is minus 2 minus 2t, not x. We are dealing with t, and minus 2 c4 sine 2t, and this is equals to 0. Ne? Then we're gonna take everything from starting from this side here to the right hand side. Then we're gonna be left with minus 4d of, this is the side of x. Then it's going to be equals to, when you take it, it's going to give us a sign of negative. This one here, when we minus, remember, is going to be minus, is going to be minus 4c1 e to the power square root of 2t minus 4c2 e to the power negative square root of 2t plus, this one is going to change to plus 2c3 cos 3t plus 2 again c4 sine 2t. So because here we have minus 4d in the side of x, we divide everything by minus 4. Then our d is going to be, in terms of x here, is going to be negative. If we divide by negative 4, we're going to be left with c1 e root of 2t plus c2 is negative square root of 2t plus minus, because it's plus, it's going to be minus 1 over 2. 2 over 4 minus 4 is going to be over 2 c3 cos 2t minus 1 over 2 again c4 sine of 2t. So now we found the equation of d. So when we found the equation of d, we use the integral based on the differential equation. When we are working with implicity, we introduced the integral so that you can get the general solution. So this one, when you introduce the integral, you will find that you are working, maybe you find that you have t plus equals to t, maybe you have dx in those equation whereby you have dy over dx, whereby your dy over x, you find that is x plus y. Let's say xy like this. So in order for you to solve this equation, you will multiply by x, then dy, you will multiply everywhere here by dx. You multiply even the right hand side by dx. Then this dx will be cancelled with this one. You will be left with dy, which is equals to xy dx. Then you can divide by dy here. Then you will have, even you divide by dy this side. Then you introduce integral, then you will have integral of 1 over y dy, which is equals to an integral of x dx. So after here is whereby you can be able to get the general solution. So we use this principle to get those, we use this method to get the, the differentiation, the answer for this one. So I'm gonna erase this part here. So when I erase this part, then I'm going to solve this this equation based on the same method that I just showed you now. So when we solve this equation based on the same way for dx, just give me 1 minute. So when we differentiate this, if you differentiate this here, when we differentiate this equation, here, we're going to get x of t. Our x of t, when we differentiate, is going to be equals to the differentiation of e to the power 2x. Remember, I'm just going to show you one method here, only differentiation of e to the power square root of x. If I have to differentiate e to the power square root of 2t dt, I will let, you can, when you're using, you can use a substitution method. So the substitution method, you can let your u equals to square root of 2t, then your du over dt is going to be equals to square root of 2. After that, you can multiply both that by dt, then this implies that your du is going to be equals to square root of 2 dt. Then you divide by square root of 2, then you're going to have 1 over square root of 2 du equals to dt. Then when you have this one here, you can substitute back here. If we work, we can say integral of e to the power square root of 2t. We gonna write it as e to the power because we let square root of 2t equals to u. When I say u, but our dt now is going to be equals to 1 over square root of 2, which was just 1 over square root of 2 outside here, du. Then when we differentiate this, we're going to get 1 over square root of 2 e to the power u. So now if you substitute back here, you can just substitute back your u is square root of 2 dt. This you can just substitute and it becomes square root of 2 e to the power square root of 2t. So now in this square root, in mathematics, we have something called in mathematics, we have something called when we rationalize, we can rationalize this 1 over square root of 2. To rationalize 1 over square root of 2, we multiply both sides by square root of 2, divide by square root of 2. Then this is going to be square root of 2 over square root of 2 times square root of 2 is going to be 2. So normally in terms of your memos and your books, you will find that normally the answers, they are rationalized. So they will be writing square root of 2 over 2. So square root of 2 over 2 is still the same as 1 over square root of 2. They are equal. So this is the method that we are going to use there. So I'm gonna erase here. Now we continue with we'll proceed with our question. So do you have any questions so far?
Can we do an exam question? One exam question?
You are fine. Are you okay?
Yes, I'm okay. The video is cutting off a bit.
Oh, okay. Oh, because of your network, ne?
Yes.
Okay. But are you grabbing something? I mean, due to
Yeah,
the
I'm
network issue.
understanding.
Okay, it's fine. Let me just, whenever you don't understand, you can ask me, but I'm gonna send you the video after when we are done. So I'm gonna erase this side. So now what we can do, when we get x of t, we're going to have square root of 2 over 2 c1 e to the power square root of 2 t plus square root of 2 over 2 c2 e to the power negative square root of 2 t. Then when we differentiate cos, when we differentiate cos, it's going to be sine, but with positive. It can't, and when we not differentiate, when we integrate cos, it's going to be sine, positive sine, and when we differentiate sine, it's going to be negative cos. We change the sign, change to negative. Then the answer is going to be negative. Here is going to be negative 1 over 4 c3 sine 2t minus 1 over 4 again c4 cos. Then because it's c here is going to be negative, it's going to change to negative times negative, it's going to be positive, going to be plus cos 2t. So now we just got the solution for x of t, and we also have a solution for y. Remember here I was just changing so that you can see what happened to get those results there. I multiply by 2. We can just eliminate 2 here, this 2, like this one and this one. Then this becomes the equation of y. So now when we proceed with this equation, then we have found this equation of xt. We have x of t, and we also have equation of x of, not x of t. Let's say we have equation of x of t, and we also have y of t. We can write them, I wrote them in a transpose. So now we can substitute back these two equations to equation number 1 or to equation number 2. You can choose any of the equation. So when we substitute back these two equations from equation number 1, you will find out that our x, because of here for the x of t, after that when we are differentiating, you must remember that when you make a integral of something, if I'm differentiating x dx, the answer is going to be x squared over 2 plus constant. So even here when we differentiate here, there will be a plus, also a constant. So this constant, we can name it C4, C5, because we already have C4 there. Can name it C5. So now when we substitute both x, y of t and x of t in one of those equations, if you add them properly, if you substitute everything there, you are going to find out that the x5 here, when you solve it, everything they are going to cancel. If you check here, this one is going to cancel with the other one, this one, all of them, they are going to cancel, and your constant C5 is going to be equals to 0. And when your constant C5 equals to 0, remember it means that this equation here is homogeneous. Homogeneous equation. homogeneous. So the final equation that you're going to have is going to be only the solution of these equations. They are going to be x of t, this one, and the y of t that we got. So just by doing that, you have answered this equation. You will have solved this linear system equation. So due to your network issue also, for today, we're going to end here. Then I'm just going to send you the video so that you can go through this. Then the next class, I think tomorrow, based on the timetable, we are still doing the same, we are still going to do the same module based on the timetables. Then we're going to do more questions about what we are doing today. We're going to take some few questions on the question papers. And if you have some question paper, you can send it to me so that we can treat them together. Then, which means I will see you tomorrow.